Hi everyone. This is Professor Oaks, and in this video we are going to discuss here polar coordinates. So the polar coordinate system first. What is this? Well, if you choose a fixed point, and you can call O, called the pole, and a fixed ray with an endpoint O called the polar axis. All right, so an angle in standard position has its vertex at the pole and has the polar axis as its initial side. So if you let P be any point in the plane and denote R by the distance from the pole to P, then the lowercase r, the distance, is the length of the line segment from the pole O to the point P. So if P is not equal to 0, then the point P lies on a uniquely determined ray with endpoint O, and the ray forms the terminal side of an angle theta in standard position. The order pair R theta, and remember that order, it's sort of like X, Y, in the Cartesian coordinate plane. It has to be in the correct order. And this is the polar coordinates of the point P. So if P is equal to R theta, the ordered pair in the polar coordinate system, then P of R theta is also equal to P of R theta degrees plus 360 degrees N, because if you go around the system of 360 degrees, you'll come back to the same point that you started at. And similarly, then, this will be the opposite of R, and theta degrees plus 180 degrees times 2n plus 1. So these are all equivalent ways of writing the same point. Now, if P of R theta, where theta is in radians rather than in degrees, then we have, all right, I'll move this up for you. P of R theta is P of R theta plus 2 pi n. So again, for degrees we had 360 degrees n, but for radians we had 2 pi n, and that will be also P is equal to the opposite of R and theta plus 2n plus 1 pi. And again, 180 degrees is equal to pi radians. So to then plot the polar coordinate R theta, that means to draw a diagram showing the pole, the polar axis, and the point P whose coordinates are R theta. All right, so let's do an example here. So let's plot the point 3, 150 degrees. So remember that's in the form R theta. So R is 3 and theta is 150 degrees in the polar coordinate system, and then give 3 other representations of the point for which R is less than 0 and theta between 0 and 2 pi, including 0 here. So let's start first by drawing the point, and then we'll get the other representations here. So remember that we need to have the pole. All right, so here's the pole, and that's O. And then we have the polar axis. So this right here is, and I'm shading it the best that I can here. So this is the polar axis, right? And we know that the theta is 150 degrees. So this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then all the way back around, we get back to 360 degrees. So we want 150 degrees, and then we want the radius, or r, to be 3. So here is 150 degrees, and then I need to draw a line segment that's 3 units long. So here is about 1 unit long, and then 2 units long, and then 3 units long. So it is sort of sometimes hard to get this as exact as possible, but just try to remember that this line segment here from the pole over to the point needs to be 3 units long. So this is theta is 150 degrees, and the length of this segment here is r equals 3. So then this point right here is 150 degrees in polar coordinates, or in the polar coordinate system. All right, now let's draw another representation for this using these conditions. So we want the r to be we want the r to be less than 0. So what are we going to do? What is another way that we can write that? Well, all right. Well, think about this then. All right. So I said that p of r theta was equal to p of the opposite of r, theta degrees, plus 180 degrees, 2n plus 1. All right, so if we have p of 150 degrees, and then I substitute in the r here, so that's a -3, and theta was 150 degrees plus 180 degrees times 2n plus 1. All right, so let's see what happens if I get n is equal to 1, and we have 180 degrees, 2n plus 1, so we have 1. There we go. So 180 degrees, 2 times 1 plus 1 will be, well, that is 270 degrees. All right, so if I add that to the 150, so 150 degrees plus 180 degrees, 2n plus 1, that will be 150 plus 270 degrees, that's 420 degrees. But remember, we want something that with between 0 and 2 pi, or 0 and 360 degrees. So that means we need this number to go lower. So let's try 0. So 180 degrees, 2 times 0 plus 1 will be 300. Let's see, 300. No, 180 degrees. I can't read my own handwriting there. So that's 2 times 0 plus 1. That's 1. So 1 times 180 of 180. And then 180 plus 150 is 330 degrees. So that seems okay. So if r is equal to -3, and the new r, right? And then we have 330 degrees here, then we need to find the 330 degrees from the pole. So here is 330 degrees, and then r equals 3 would be 1, 2, 3, but we want the point to actually be over here. So this would actually be p of 330 degrees, but what we want is it to be over here. So to get the point to be over here, we reflect it, and we end up with P of negative 330 degrees. So in other words, 150 degrees, and negative 330 degrees are the same point. And if we want this to be in radians, then 330 degrees, all right, so remember to try to write this in radians here. Yeah, so that will be what, 11 pi over 6. So negative 3 and 11 pi over 6. All right, so let's do another one here. So we want the theta to be between negative 2 pi and 0. So a negative number now. So in other words, that's the same as saying between negative 360 degrees and, let's see, 0. So we can do this now, and remember, another way to do this might be to look at this diagram and see how many degrees negative we could go around the axis here. So if I want the point to be over here at 150 degrees, if I look at the negative angle over to that point, then I can see easily it is negative 210 degrees. All right, so again, this will be negative 90 degrees, negative 180 degrees, negative 270 degrees, negative 360 degrees. So going the clockwise direction around the axis, the axis here, and so this is also 3 negative 210 degrees, right? Or another way to write this would be 3, and in radians, it would be, what was that, negative 7 pi over 6. So hopefully you are doing okay with converting all of these uh, from degrees to radians, and you see where this is happening now. So here's another one. So let's say I want r to be less than 0, but I want the angle to be negative. So if I already can steal the diagram from over here, because I already drew what is going to happen here. So if r is negative, so here is 1, 2, 3, and now I just look at the negative angle to this point, and that will be theta is negative 30 degrees. So this is P of 3 negative 30 degrees. But if I want the point to be over here, then the point is now negative 3 negative 30 degrees. All right, so in other words, if I write this in the radians, what is it? It's negative 3 negative pi over 6. So all of these points are exactly the same. 3, 150 degrees, or negative 3, 330 degrees, or 3, negative 210 degrees, or negative 3, negative 30 degrees, and there's infinitely many different ways that you could represent the same point in polar coordinates. All right, so now let's look at the conversion of coordinates here. So here we go. So the equations x equals r cosine of theta and y equals r sine of theta work in all possible cases to convert the polar coordinates r theta of a point P to the Cartesian coordinates x, y of P. So furthermore, r is equal to plus or minus the square root of x squared plus y squared, and the tangent of theta equals y over x if x is not equal to 0. So, however, the equations do not uniquely determine r and theta because the point P, whose Cartesian coordinates are x, y, has an unlimited number of different representations in the polar coordinate system. So that's what we just talked about, is that there's unlimited ways to represent the same point. So you can see that even in this case, we found 4 ways to represent the same point. This is like Subway and all their different ways that you can make a sub, toasted or untoasted or whatever you would like on it most of the time. So thus, you must pay attention to the quadrant in which P lies in order to correctly determine theta. So let's convert the given polar coordinates to Cartesian coordinates. So 6, 13 pi over 6. So we know that this is 6, and 13 pi over 6 minus 2 pi, or just 6 pi over 6. And this makes it easier so that I don't have to keep on circling around the 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 coordinate system here several times to figure out where the point is at. So here is theta equals pi over 6, and then I need to draw this r equals 6, so 1, 2, 3, 4, 5, 6, and so here is the point. All right, so how do I convert this to Cartesian coordinates? Well, x is r cosine of theta, so r was 6, and theta was 13 pi over 6, or pi over 6, so 6 cosine of pi over 6, and the cosine of pi over 6 is the square root of 3 over 2, so that will be 3 square root of 3. And now y is r sine of theta, so that's 6 sine of pi over 6, or 13 pi over 6, and that's 6 times a sine of pi over 6, which is a half, and 6 times a half is 3. So now you know that in Cartesian coordinates, the same point is x, y is 3 square root of 3, 3. And you can see right on the graph here, if I draw the triangle here, that, well, if this is actually pi over 6, then I know it is a 1, 2, 3 triangle. So this is 3, 3 root 3, and then this, yeah, ooh, yeah, this looks like it's a lot. It might seem like it's a lot, but it's really not. This is, again, this was r equals 6, so this is 6. So hopefully this will make sense that you could find these just by doing basic trigonometry as well. All right, so B, the point negative 15, 150 degrees. So let's draw this out here. So we want 150 degrees. So 150 degrees is right here. So theta is 150 degrees, and r is 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's over here somewhere, but this is r is 15, but we want it negative 15. So the point is actually over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here is the point over here. And this is, again, negative 15, 150 degrees. Now, in Cartesian coordinates, we have x is r cosine of theta, so that's negative 15 cosine of 150 degrees, but cosine of 150 degrees is negative root 3 over 2, so that will be 15 root 3 over 2. And then y is r sine of theta, so that's negative 15 sine of 150 degrees, or negative 15 times a half, so negative 15 over 2. And so then in Cartesian coordinates, this is xy is 15 root 3 over 2 and negative 15 over 2. All right, so now let's look at another example here. Convert the given Cartesian coordinates to polar coordinates r, theta, with r is greater than or equal to 0, and theta is between the opposite of pi and pi, but including pi here. So remember, these are in xy now, and we're converting them to r theta format. All right, so let's first draw what we have here. So x is negative 5, 1, 2, 3, 4, 5. And y is 5, 1, 2, 3, 4, 5. And we want to figure out what this point is in polar coordinates here. All right, so, well, remember that we want r to be greater than or equal to 0 and theta between negative pi and pi. So r was equal to plus or minus the square root of x squared plus y squared, and that's the square root of negative 5 squared plus 5 squared, and then that's actually 25 plus 25, or 50, under the square root. So remember, it needs to be positive and not negative because we said r must be greater than or equal to 0. So now the tangent of theta was y over x, and y is 5 and x is negative 5. So that means tangent of theta is equal to negative 1. And if I take the tangent inverse of negative 1, that will give me 3 pi over 4. So this is theta is 3 pi over 4. So that's it. All right, so the r is the square root of 50, and then the theta is 3 pi over 4, so the point negative 5, 5, convert it to the polar coordinates is square root of 50 and 3 pi over 4. All right, let's try another one. Negative 2, 0. So here we go. X, Y. X is negative 2, and y is 0. So negative 2, 0. And then what we have here is, well, actually, this is one that you can sort of look at here because this is negative 2, 0, and you know the length of this is r is 2, and to get over to this point, we went pi, or 180 degrees. All right, so therefore, r theta would be 2 pi. Or you could do the formulas, or use the formulas. R is equal to plus or minus the square root of x squared plus y squared. So that is the square root of negative 2 squared plus 0 squared, again, since r had to be greater than 0 here. And that's the square root of 4, and the square root of 4 is 2, or 4 plus 0, it's still 2. And the tangent of theta is y over x, or the tangent of theta would be then 0 over negative 2. So tangent of theta is 0, and the inverse tangent of 0 is a 0. So you wanted this again to be between the negative pi and pi. So you want the theta to be between the, and I'll label this theta equals, but you want this to be between the negative pi and pi, but 0 is um, is okay, but remember that theta could also be 0 plus pi, and therefore we get pi. All right, so that is another way to write this. If you just put 0, then that is it's actually a bit strange because this is a 0 angle and you want it to go over to be on this side. So r would have to be negative in that case to reflect it back over here, but r needed to be positive. All right, so now on to the graphs of polar equations. So a polar graph is an equation relating the polar coordinates of r and theta, and the graph of a polar equation consists of all the points P in the plane that have at least one pair of polar coordinates r, theta satisfying the equation. So there's another note on the next page. If a is greater than 0, then r equals plus or minus 2a cosine of theta is a circle with a radius a and center plus or minus a0, and r is equal to plus or minus 2a sine of theta is a circle with radius and center at 0 plus or minus a. So please try to remember this for the rest of your life. Now sketch a graph of each polar equation now. So remember that these are all in r equals format. So r squared equals 9 is the same as r equals plus or minus 3 once I solve for r. Now remember that also r was equal to plus or minus the square root of x squared plus y squared. So these are both equal to each other. So we have plus or minus 3 is equal to plus or minus square root of x squared plus y squared. If we square each side, 9 is x squared plus y squared. And we see this is a circle with the center 0, 0, and the radius of 3. So here is a graph of what this would look like. All right, center 0, 0, radius 3. So here we go, radius 3. And this is the equation of the circle and what the graph of it would look like. All right, let's look at the next one. Theta is equal to, if we solve this equation for theta here, theta squared is 25 pi squared over 36. So if we take the square root, theta is equal to plus or minus 5 pi over 6. All right, so here we go. Here is 5 pi over 6. Theta is 5 pi over 6. And then this is what it looks like. So if r is actually greater than 0, we would have all of these points. And if r is less than 0, we have all of these points. So this is actually a line. This is a line. So theta equals 5 pi over 6 is a line. You don't even need the plus or minus because you can make r positive or r negative and get all the points on that line. All right, let's graph another one. Theta is equal to negative 5 pi over 4. So I don't know if you've seen the pattern yet, but r equals c is the equation of a circle, and theta equals k is the equation of a line. So this is a line. So let's graph this. So all we need to do is figure out where negative 5 pi over 4 is, and negative 5 pi over 4 is somewhere over here. Theta is negative 5 pi over 4. And in this case, these are all of the values on the part of the line where r is greater than 0 and when r is less than 0. All right, here is an interesting equation here. Theta squared minus 4 pi over 3 theta plus 7 pi squared over 36 equals 0. So what I'll do is I'll start by clearing the fraction, and I'll just multiply by, say, what would be a good number. How about 36? All right, so we have 36 pi squared minus 48 pi theta plus 7 pi squared equals 0. And now I can factor into 6 theta minus pi. 6 theta minus 7 pi equals 0. And so then 6 theta minus pi could be 0. 6 theta is pi, or theta is pi over 6. Now 6 theta minus 7 pi could be 0. Add the 7 pi to get 6 theta is 7 pi. Divide by 6 to get 7 pi over 6. And if you notice, these are both lines. Here's a line. Here's a line. But in all honesty, if you graph them, or maybe you've already noticed, they're going to be the same line, because here is pi over 6, and then here is 7 pi over 6. So these are actually the same line. So this is the solution here. All right, now convert each Cartesian equation to a polar equation and then sketch the graph. So y equals negative 2 is a line, right? So x, y, negative 2 is y, so here is a line. So we know that this is a line. Now, just remember this, though. This is a little bit tricky here. All right, so here's a sketch here. So x will be r cosine theta, y is r sine of theta. So y is r sine of theta, so r sine of theta will be negative 2. And then I can divide by sine of theta. So r is negative 2 over sine of theta, or r is negative 2 cosecant of theta. So this is a line, but the equation of it was maybe different than what you may have been expecting. All right, so now here's another one. X squared plus y squared equals 4x. So remember what I said just now. In polar coordinates, or to convert to polar coordinates, we have, here we go, x is r cosine of theta, and y is r sine of theta. So if I substitute these into the equation, I have r cosine of theta squared plus r sine of theta squared is 4r cosine of theta. I'll square this to get r squared cosine squared theta plus r squared sine squared theta equal 4r cosine of theta. Then factor out r squared here to get r squared cosine squared theta plus sine squared theta is 4r cosine of theta. Then use a trig identity, and sine squared theta plus cosine squared theta equals 1, or cosine squared theta plus sine squared theta equals 1. So we have r squared times 1 is 4r cosine of theta. And then if I divide out in r here, we have r is 4 cosine of theta. And then we can write 4 as 2 times 2 cosine of theta. And if you remember, r equal plus or minus 2a cosine of theta was a circle with radius of r and a center at plus or minus a 0. So in this case, the a is 2, and so the center will be at 2, 0. All right, so now just remember that here. All right, so we have a sketch of this now, and the center is at 2, 0, and the equation is 4 cosine of theta. So here we go. So theta in r is 4 cosine of theta. So if theta is 0, then 4 cosine of 0 will be 4. So there's a point right here. All right, if theta is pi over 2, 4 cosine of pi over 2, and the cosine of pi over 2 is uh, well, it's 0. So at pi over 2, we should have a point at 0. And then at 3 pi over 2, we have 4 cosine of 3 pi over 2. That will give us a 0. And then if we go back to say even something like what you want to try here. Let's try, say, even a 2 pi, 4 cosine of 2 pi. That will give us 4. So we're back to where we start. So this obviously is not a circle, but we know this is the center. Now we can see that it had a radius of 2. And this is what it looked like. All right, so if you wanted to get this point, what's something that you could pick? Well, you could have picked something like, let's say, pi over 4. All right, so 4 cosine of pi over 4. And this will be 4 times root 2 over 2, or 2 root 2. All right, so that will be this point right here. And then, well, 2 root 2. And then, if you want this point down here, well, what's another point that you could pick? Maybe a what do you want to pick? Like 3 pi over 4. So 4 cosine of 3 pi over 4 All right, so 3 pi over 4, that will be 4 times negative root 2 over 2, or negative 2 root 2. That will give you this point over here. So again, let's recap. In polar coordinates, this was the point 0 and 4, and this was the point, oh, sorry, 4, 4, 4, 0. Sorry, 4, 0. Because remember, we want r theta, and this is the point, let's see, 2 root 2 pi over 4, and this was the point, here we had it, right, 0 pi over 2, and this was the point, negative 2 root 2, 3 pi over 4. So again, you could do this all in polar coordinates if you wish to. Now, as a side note, if you want to do this without the polar coordinates, and who knows, you might find this easier, you might not find this easier, but x squared plus y squared is 4x. Remember that you would need to add or subtract the 4x, so minus the 4x here. So let me make this a little bit nicer here. So minus the 4x plus y squared is 0. And then we'll complete the square. So x squared minus 4x plus 4 minus 4 plus y squared is 0. Factor x minus 2 minus 4 plus y squared is 0. Then we have x minus 2 squared plus y squared, add the 4, is equal to 4. So this is in the format x minus h squared plus y minus k squared equals r squared for a circle. So the hk is the center, and that will be the 2, 0. And the r would be the square root of the 4, which is 2. And then you see that you could have drawn this in Cartesian coordinates by just finding the equation by completing the square and then plotting some points. All right, let's move on to the last part of this section on polar coordinates here. Let's convert each polar equation to a Cartesian equation and then sketch the graph. All right, so remember I said x is r cosine of theta and y is r sine of theta. And r squared is x squared plus y squared, or r is plus or minus the square root of x squared plus y squared. All right, so here I need to convert this to x's and y's, but I need r cosine theta, r sine of theta. So I'm just going to multiply each side by r. So r squared is 2r cosine of theta plus 2r sine of theta. Now r squared is x squared plus y squared, and r cosine of theta is x, so that's 2x. R sine of theta is y, so that's 2y. And then I can use completing the square just like I showed in the last example. So x squared, I'll subtract the 2x plus y squared, subtract the 2y equals 0. Then complete the square, plus 1 minus 1. And then again, plus 1 minus 1 equals 0. So we have x minus 1 times x minus 1 plus y minus 1 times y minus 1 equals 0. Or x minus 1 squared minus 1 plus y minus 1 squared minus 1 equals 0. Add the 1 to get x minus 1 squared plus y minus 1 squared is equal to 2. So this is a circle with a center of 1, 1 and a radius of the square root of 2. All right, the square root of r squared, which was 2. And now I can draw a sketch here fairly easily. And here is the center, 1, 1, and a radius of the square root of 2. So a radius of the square root of 2. So it's, you know what, like this is going to be fairly like just a sketch to begin with. So just remember that this is just a sketch here. And there you go. Let's try another one here. R is secant of theta. So since I know that x is r cosine of theta and y is r sine of theta, I'll convert the secant theta to 1 over cosine of theta and then multiply by cosine of theta. So r cosine of theta is 1, but r cosine of theta was x, so x equals 1, and this is just a vertical line. So here's a sketch of a vertical line. Hopefully you've seen one of these before. Here is x equals 1. Here is the vertical line. Done! What a time to be alive! Now, let's try another one here. Let's start by multiplying by 2 cosine theta minus 3 sine of theta on each side. So r times 2 cosine of theta minus 3 sine of theta equals 1. Let's distribute the r. So we have 2r cosine of theta minus 3r sine of theta equals 1. But r cosine of theta was x and r sine of theta was y. So 2x minus 3y is 1. But then I can go ahead and just subtract the 2x and divide by -3. So I have y is 2/3 x minus 1/3. And this is a line with the slope of 2 over 3 and a y-intercept of -1/3. So let's sketch this today. All right, don't delay, sketch this today. And the y-intercept is at 0, -1/3, and then if I label these by 1/3, so then I can do this fairly easily. I go up 2/3 and then to the right 1. All right, so this is 1/3, and this is what this looks like. All right, it's a line. So hopefully this section is not as bad as it could be, because all we did here in this section was graph a line in a circle and maybe do a little bit of basic trigonometry with sines and cosines to convert these Cartesian equations into polar equations, and points in polar coordinates into Cartesian coordinate points, and the other way around as well. So I hope you enjoyed this video and that you're already looking forward to the next one. Have a great day, and what a time to be alive.